Hello, dear friends. This is Mike, a.k.a. the Duke of Highway J. So last fall, my bride Jody and I were walking around Minneapolis looking for a cup of coffee when we stumbled across the Chicago Avenue Fire Arts Center, a makerspace for all things involving hot metal. Needless to say, I was smitten. To make a boring story short, within it was the most amazing clock I had seen in quite a while. Standing approximately 12 feet high, it was two large roller chains with flame-cut numbers attached, one for minutes, one for hours, and whatever number was vertical at the top represented the appropriate hour or minute. Get it? Fast forward a couple weeks, when I realized I had no clock within my modest garage workspace. And having dreamt about the Chicago Avenue Fire Arts Center clock, I envisioned and then designed a horizontal implementation of that design. Two horizontal roller chains supporting minutes and hour numbers, courtesy of the Wisconsin Motor Vehicle license plates, with a lighted bar that acts as the marker for both the current, minute, and hour. So what we have here is an ESP8266 module to get the current time from the network time protocol, which is one of the things the interweb does. And it sends it to an Arduino Pro, which, along with monitoring a PIR, passive infrared sensor, and a couple of limit switches to verify the position of the chains, feeds to a couple of Pololu motor controllers driving stepper motors that I scrounged out of a scrap scanner or two that were augmented into almost actual gearboxes, one of which is pretty noisy. It also drives a MOSFET to control the light bar, which, by the way, is PWM controllable, so I could do some pulsing or fancy fade-up, fade-downs, but I haven't yet. Add a Chinese switching power supply module and a bunch of software, and we're good to go. Yes, the 8266 shown here could have handled everything, but this is a fancy one and not the $3 one I started with, and that's a long story. But as long as I was designing the world's most needlessly complicated clock, more parts the better, right? Besides, I have a bucket of these Arduinos, which cost me all of $3 each. So starting the clock cold, or boot up, as we say, we see the hour and minute chains finding their reset position via the limit switches, while the ESP8266 gets the current time off the interweb, after which the clock updates to the correct time. Thereafter, every 2 minutes, the clock updates itself if someone is present as detected by the PIR. I mean, there's no sense grinding gears when no one's around, right? Other than the 8266 acting as a web server to inform anyone as to the date and time currently at the garage at GarberPark, that's pretty much it. Much thanks to the open source OpenSCAD design software, and of course the East Troy High School Fab Lab for access to their laser engraver and 3D printers to make this fiasco possible. Thank you.